Okay, so the problem says that we have been given an array of integers nums of size 3, and we have to return the maximum possible number whose binary representation can be formed by concatenating the binary representations of all elements in numbers in some order. And note that the binary representation of any number does not contain leading zeros. So the problem is saying we have been given an array of three integers. So let's consider the three numbers as a, b, c. We are being told that we will convert these integers into their binary representations. So let's say if a was equal to 10, its binary representation will be 1010. Similarly, if b was 5, its binary representation will be 101. And if c was, let's say, 7, then its binary representation will be 111. Then for all of these three binary representations, we have to combine them in some order. In which orders can we combine them? Um, let's say if I'm calling these binary representations as a1, b1 and c1, then I can combine them in either this way: a1 plus b1 plus c1, or a1 plus c1 plus b1, or in any order. I know there are three integers, so there will be six possible combinations for concatenating them. Let's say we concatenated them as a1 p1 plus c1. Then the final binary representation, like the new number we will have, will be 1010 101 111. This will be its binary representation, and then we will convert this to the decimal form, and whatever decimal which we get, we want this thing to be maximized as much as possible. So out of all the six combinations we will have, what will be the six combinations? These are two of them. Then the third one will be p1 plus a1 plus c1, b1 plus c1 plus a1, um, c1 plus a1 plus b1, and c1 plus b1 plus a1. These are the six possible combinations. Out of them, whichever decimal value we are getting as the maximum, we have to return that. So does this make sense? Please tell me in chat, is the problem clear of what we have to do? I'm waiting for your responses in chat. Okay, Govind is asking. I think Govind is trying to ask about the time complexity, that if we have an array of uh, 10 raised to the power 5 number of elements, then will n log n work or not? I think this is what you are trying to ask. So yeah, it will work. If you have the size of the array till 10 raised to the power 5, then n log n or even n log square n can work. Okay, very well. If this is clear to everyone, then uh, yeah, this is, let's come here. So how will we do it? Let's just try to brute force it. How will we brute force it? We don't really care about the time complexity. We just want to find the solution. So we did notice that from the given numbers, we can easily create their binary representations. Once we get those binary representations, we know that there are only six combinations. So what we can do is, for each and every one of these combinations, we can find out uh, the binary representation after concatenating them, and from those binary representations we can find out the decimal values which we will get, and among these decimal values, whichever is the maximum one, we can just return that. So this is a complete brute force. So the idea is there are six combinations. है ना? Like I think this much is clear that there are six combinations. For each and every one of them, let's say if we are talking about a combination A1 plus B1 plus C1, then first of all we will concatenate them. Can sorry, concatenate them, and we will get a binary string. Then we will find out the decimal value. We have got the decimal value. Now whatever we have got here, we will just find out that same thing for the other six combinations, and whichever final decimal value is the maximum one, we will just return it. Does it make sense? uh, Govind, what you are asking is actually not related to this problem, so let's discuss it at the end. Guys, please tell me about the problem. Is the logic for the problem clear? Now the main thing is, first of all, from the given numbers a, b, and c, you should be able to find out the binary representations. This is the first sub problem you can create for from this problem. Then concatenation part is very simple. You just have to write like this, and after that, this is the part for uh, converting numbers from binary to decimal. So you should know about converting the numbers from binary to decimal as well. And these are very famous problems for beginners. Whenever someone starts coding, most likely he or she do this problem. So I'm expecting that you already know about it, and if you don't know about it, you can just search about this on internet. Maybe I can show this to you. um, just search this on internet. um, can't search it. Okay. Binary to decimal C++. You will get the problem and you can just practice it here. You will even get the solution there. Okay, so I hope that this problem is clear. Now let us look at the code. Now in my case, I created two functions. First one is the function with the name binary. It will take an integer and as input, and it will return the binary string as output. And similarly, I created a function which will convert a binary string to an integer. And then in the main function which I had to complete, first of all, I converted these numbers to binary strings. After that, I'm doing this process. This is the concatenation part, as we had written here. And after that, I'm converting them to decimal, and we will get this thing. And we are doing the exact same thing for other five combinations, and then we are taking the maximum one of all these six combinations. Someone is asking, can I use predefined methods? Yeah, if you know about the predefined methods, you can definitely use them. And okay, so yeah, nextly the thing is, I'm giving you a to do. So the to do is that even if you don't write this decimal function here every time, and you just compare the like the concatenated strings, and then you find out the decimal value for the largest string, then the solution would also be correct. This is a to do for you. Try to prove it. I'm telling you that this is gonna be true, and the task for you as a follow-up problem is to prove it. So now let's look at the time complexity. First of all, we are converting these numbers to strings. So it would be nothing but big O of log of a, where a is the like limit for the values, or maybe let's say it log of mx. And then we are just doing this, and it would also be not so costly. maybe we don't even need to find out the time complexity because the constraints are really really small. The numbers would be at most 3 digit in size. So uh, there is definitely no problem related to time, and the same thing goes for space. It was just an implementation based problem then, where you just had to implement and you don't really care about the time and space. Okay, so guys, shall we move on to the next problem? um, please say yes or no in the chat. So I'm not able to solve problem, please. And login means okay. So in the meanwhile, I can tell you about what is login. So wherever you read that nlogn, it is actually referring to um, n multiplied with log of n. So if n is, let's say, equal to 10 raised to the power 5, then log of n, in general, when you see log of n, they are actually referring to log 2 of n. At least uh, in all the editorials you will see related to coding, generally people don't write log 2 n, instead they just write log n. So this log of n would here be around equal to 17 or 18. For this 10e5 is 10 raised to the power 5 is the value of n, 17 or 18, whatever. So n log n should be around 10 raised to the power 5 into 17 or 18. Let's call it as 18, and it will be around 1e6 to 2e6. Let's say 2e6 in the worst case. Um, and to be honest, Govind, I'm not really able to understand what you are willing to ask, because mm, the question is not really making much sense. I have one question, but if the given array size was more than 3, how can we do it? Yeah, actually, even if the problem, uh, like somebody asked in chat that for this problem, I hope I can delete everything. No, I can't. No. Okay, let's create a new page. Yeah, so somebody asked that in the problem A itself, if n could have been greater than 3, then how could we solve it? And this is actually a problem already available on internet, in which you are being given an array of some integers. Like you would be given some array of integers, maybe 87, 82, 97 or something, and you will have to find out what can be the largest possible number formed by concatenating these numbers themselves. So in this case, the maximum number you can form is 978782 by concatenating them, right? So I won't really discuss the complete solution for this problem, but it was done by sorting these numbers, where you decide that the number, like, first of all, you can convert these numbers to strings. So even if there is a string like, okay, let's say this was, maybe, just one second, let me take one good example. So in the problem which I told you, that you would be given an array of integers and you will have to uh, concatenate the numbers to form a very big number, right? So if you have something like 1, 4 and 5, even though the number 14 is bigger, the largest number can be formed by concatenating them as 5 and 4, right? So uh, the way of solving this problem, maybe I should not, yeah, for now I'm just telling you directly about the solution, because this is not even related to contest, and you already have a lot of solutions online which discuss the complete intuition and everything. So in this case, you could just sort them in such a way that if there are two numbers 14 and 5, you would check, is concatenating them like this is giving you a bigger number, or concatenating them as this is giving you a bigger number. Obviously this is giving you a bigger number, so 5 should come before 14 in the concatenation. And you can use a similar logic for the sort function. Like whatever sort function you apply, you can use a similar logic there as well. Yeah, the rest is something you can, first of all, you should try to think on your own. And if you can't do it, then maybe look at a solution online. Okay. I think we kind of use permutations of them and correct. Yeah, you can find out all the permutations as well. For the problem, for this problem, we did actually find out all the permutations only. So we can sort, and then if a more than 3. Okay, so let's move on to the next problem. The next problem is remove methods from project. This problem says we are maintaining a project that has n methods from 0 to n minus 1. We are being given two integers n and k, that is nk, and a 2D integer array invocations, where invocations of I is equal to uh, ai comma bi, basically an array of size 2, that indicates that method a will invoke the method b. There is a known bug in the method k, and we are being told that method k along with any method invoked by it, either directly or indirectly, are considered suspicious, and we aim to remove them. A group of, okay, first of all, let's discuss till this point. So we are being given an integer n, an integer k, and a 2D array with name invocations. The dimensions of this 2D array are, uh, okay, the number of, the size of this invocations array or vector can be anything. It would be basically a vector of vectors of size 2 2. Okay, let's call this as m. So we are being given an integer n, an integer k, and a 2D array of size of dimensions m and 2. This m is something we have just declared for this. Uh, so invocations of I will actually have two integers ai and bi, which says, like, which is telling me that a method ai will invoke method bi. Yeah, that's it. That's what this invocations of I is telling us. And we are being told that the method k is considered a bit suspicious, or yeah, there is a bug in the method k. So whatever functions this method a invoke, let's say method k invoked function 2, function 7, and maybe function 9, then this method and all the methods which are being invoked by method k would be considered suspicious. Then we are being told that a group of methods that can only be removed if no method outside the group invokes any method within it. So yeah, and after that we are being told that we have to return an array consisting of all the remaining methods after removing the suspicious methods from uh, all the methods which we have been given, and we can return the answer in any order. And uh, if it is not possible to remove all the suspicious methods, then we will not remove any one of them. So it tells us that we had n methods, that integer n was actually telling us that there are n methods and the method k is faulty. So if, let's say, there are four methods, n equal to 4 and method k equal to 1 is faulty, and the invocations are like this: uh, 1 invokes 2, 0 invokes 1, and 3 invokes 2. 3 invokes 2, uh, like this. So in this case it would look like this. The problem has already given us a good hint by uh, representing this invocations array as a graph. This has already given us a hint that maybe we can also represent it as a graph. Some people who are just new and have not solved a lot of problems might have not got the idea directly, but after looking at this they could have got the idea that let's represent them as nodes of a graph. So you have method 1 which invokes, sorry, method 0 which invokes method 1, method 3, okay, method 1 invokes method 2, and method 3 invokes method 2, right? So the method 1 is faulty, this one is a faulty one. So all the methods which are invoked by this method directly or indirectly would also be faulty. So method 2 would also be faulty, right? Thus we would like to remove both of these methods from this set of all the methods. So the next thing which we were being told will now come into use, that a method, like a group of methods, can only be removed if no method outside the group invokes the method within it. So if we want to remove these two methods, there should be no other method in this complete graph which invokes either one of them. Or in simple words, there should be no such edge, uh, there should be no edge where here we have a faulty method or a suspicious method being invoked uh, by a non-suspicious method. If it happens that a non-suspicious method is invoking a suspicious method, then we won't remove the methods, otherwise we will remove all the methods. So in this case 3 and 0 are invoking these two functions, thus we won't remove any of the functions. So guys, does this problem make sense? Let me discuss one more example. Actually we will discuss all the examples here. Okay, so this is the example 2 in which we have been given um, n equal to 5, k equal to 0, I think, and 1 2 0 2 0 1 3 4, basically this graph. Um, yeah, so we have 0 1 2 and 3 4. This is the graph. So here the faulty method is this one, it will invoke this and this both functions. So we want to remove all of these three because these three are the only suspicious methods. Is there any method which is invoking either one of them and is not suspicious? Yes or no? Guys, tell me in chat, is there any method which is invoking any one of them directly or indirectly other than these suspicious methods? Okay, no, 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 great. You can see that there is no like other than these three, even if you look at it, other than these three methods, there are only two methods, and none of them are able to invoke this. So we can safely remove all of these. So the remaining methods which we will have at the end of the day are gonna be only 3 and 4. In the earlier example, we had 0, 1, 2, 3. Since we could not remove any one of them, we had all the 4 remaining. Now we have 3 and 4 remaining. Uh, Great. Okay, so let's take the third example as well, which is this: n equal to 3, k equal to 2, 0 invokes 1, 1 invokes 2, and 2 invokes 1. And the faulty one is this one. Uh, Second, it will uh, invoke 0, which will invoke 1. So all of these three are faulty. Basically, not faulty, but suspicious. So is there any method which is not suspicious and is calling it? No, there is no such edge. We can just look out for the edges. We don't even care about the nodes which are invoking them. We can just look out for all the edges, that is there any edge that is non-suspicious and it invokes a suspicious function. If there is any such function which is being, like if there is any such edge like this one, then we won't invoke any function. So right now there is none. So we can safely remove all of these methods and thus we won't have any method remaining. So I hope the problem is clear and the logic is very simple. First of all, since we already know about the kth node, like we know about the node which is having the bug, we can run a DFS from this node to find out all the suspicious nodes, right? We can find out all the suspicious nodes with the help of this DFS. After that, we can just we were being given this array invocations. This is nothing but the edges. So we can check for each and every edge. Check for each and every edge if there is any such edge or not. If you find out any of these edges, then you will directly give the output as 0 till n minus 1 because you won't remove any of the methods. But if you don't find any such edge, in that case, other than the nodes which were uh, in this, like which were suspicious, other than those nodes, you can just return everything. Is the problem clear? Yes or no? If anybody has any doubt, feel free to ask it if you have any doubts. And otherwise, just write code in the chat. So we will move on to the code. You can have like 30 minutes, oh, sorry, 30 seconds break. And just as another confirmation, is the audio quality coming good? Okay, let's move on to code then. As we discussed, the first thing which we want to do is do a DFS. So for doing a DFS from this vector of integers, earlier they had named it as invocations, but this was a big name, so I changed it to edges. With the help of that edges array, you can create the adjacency list, and with the help of the adjacency list, you can run a DFS. Some people might find it confusing because I have uh, written the DFS function by writing a lambda function. If you feel it confusing, then feel free to just write the normal DFS, and like the normal way in which we write the DFS as this. Oops. You can just write it in this way. In that case, you will have to take out a lot of inputs. So that is why I try to avoid this type of function and create it within the function so that I won't have to pass on the adjacency list or the visited array as inputs for the DFS function. In the DFS function, we are doing nothing but uh, just traversing to all the nodes where you can reach from the uh, node with the bug. After that, all the nodes which you can reach from the kth node, basically all the suspicious nodes, would be visited, and all the non-suspicious nodes won't be visited. So now you can check for each and every edge that if there is any edge where a non-suspicious node is having an edge to a suspicious node, like the edges are from U to V, right? So I'm checking that if U is not visited, which means that U is uh, like if you find out that U is not visited, it means that U is not suspicious. And if V is visited, it means V is visited. Sorry, V is suspicious. So in that case, you know that you have to take all the edges now. So either you can just create an answer variable and return it directly in answer vector, or you can do it like me. I just stored it in a bool variable that here I found such an edge, and after that uh, I will just iterate over all the nodes. In case if this variable is true, it means that I have to take all the edges, sorry, all the nodes. Otherwise, if this was false, then I will see that the node must not be visited. The node must be non-suspicious. Only in that case, I will uh, take it. Like I will return it in the answer. And then at the end, I'm just returning the answer. So the time complexity will be um, this will have big O of edges time complexity. Let's say that there are m edges. So big O of m time complexity here. And this one is gonna have big O of n time complexity while creating this vector. Again, while creating this vector, you will have big O of n time complexity. This DFS function is being called only once, and it will have at most big O of n time, sorry, n plus m time complexity. And this is gonna have big O of m time complexity, and this one will have big O of n time complexity. So from all of these, it looks like the time complexity can be said as big O of n plus m. And for the space, we created this adjacency list in which we will push all of the edges one by one. So the space complexity should be big O of n plus m. At least we are taking big O of n space, and then we are pushing all of these, so it will have big O of n plus m space. And other than this, we are just creating this vector which will have big O of n space, and thus we can just say that the overall time and space complexities will be this. In Java, any lambda function? Yeah, lambda functions are there in Java as well, but I don't know if you can write a recursive lambda function or not in Java. Okay, so guys, is this problem clear? Should we move on to the next problem? And let me read the chat till then. Check that means checking. Uh, where is the check that? Uh, okay, I you're asking about this, Sanjeev. Are you asking about this? Can you dry run the code? Yeah, I will do dry run. I can do dry run. But before that, Sanjeev, can you please mention, like, can you please tell, were you asking about this part of code, the doubt you asked? Can you zoom in TH3 code so I can take SS? How can I zoom in? You will get the submissions links, by the way. Right after the contest, I will give you the submissions links in the description. Okay, so uh, Sanjeev, we are checking this part because we have been told in the problem that a group of methods can only be removed if no method outside the group invokes any method within it. So if there is a group of nodes, like if there are some nodes and you want to remove this group of nodes, then you can do it only if there is no other node which is outside the group and invokes it. If there is any node which is not in the group and it invokes a function within this group, in that case you cannot remove the nodes. So that is why we are checking that if there is, like if there is any function, like if there is any method which invokes a method which is coming up in the group, in that case there will definitely be a node, sorry, there will definitely be an edge, right? So you can just check for all the edges, though there is another way as well. If you want, you can actually run a for loop for all the edges. Oh, sorry, we have zero based indexing. If u is suspicious, then continue. Otherwise, if u is not suspicious, then go on for all the v, for all the nodes where, like all the methods which you will invoke, for all the nodes which would be invoked by you, all the methods which would be invoked by you, check if there is this condition being applied there. And I think you must have got the idea. But directly or indirectly, you are still doing the same thing. You are just checking for all the edges. So let's keep it simple for the explanation purpose. From any no suspicious, then we don't remove. Okay, so if you don't have any edge where from non-suspicious to suspicious, if you don't have any edge like this one, in that case you can safely remove all of these nodes, all of the suspicious nodes. But you can't remove the suspicious nodes if there is any such edge, or basically if there is any such method which is invoking a suspicious method. So Sanjeev, is this clear? And let me show you a dry run. So let's dry run the second problem maybe. In the second problem we have something like 0, which is the bad note. invokes 1, and it invokes 2, and 1 invokes 2, and 3 invokes 4. So this is the given thing. These are the inputs. After that, you will run the DFS. So after running the DFS, you will have a visited array, right? You will have this visited array. You will first of all mark 0 in the visited array, that 0 is visited. Then you will visit 1, and you will visit 2 as well. So 0, 1 and 2, all of these would be marked true in the visited array, and there are no other nodes which would be visited by running the DFS function from the node 0. After that, there are 4 edges. If you can see, there are 4 edges. Edge from 0 to 1. Yeah, now 0, 1 and 2, all of these are suspicious since these are visited, and 3 and 4 are not suspicious. So the edges you will have now are gonna be from 0 to 1, from 1 to 2, from 0 to 2, and the edge from 3 to 4. Now you can see for all of these edges, there is no such edge where a non-suspicious node is calling or invoking or actually pointing to a suspicious node, right? There is no such case. So we can say that we will the variable which we had with name take all will stay false. So now among all the nodes which we had 0, 1, 2, 3, we will iterate over them, and we will see that nodes 0, 1 and 2 have been marked visited, so we will not pick them in our answer. But node 3 and actually node 4 as well, node 4 are not picked up. These are not visited, so yeah, we can pick them up now. So in our answer, we will have nodes 3 comma 4. This will be our answer. So does it make sense? I hope dry run made this a lot more clear. Hanumant, can you please say something? Or otherwise we can move on if nobody has any doubts. Okay, great if it is good now. Yeah, so let's move on to the third problem. The third problem, it had the least number of submissions. Uh, at the last moment, it got a lot of submissions, probably due to cheating. Nowadays, cheating is happening a lot. Otherwise, it had a lot less submissions. But actually, the problem is simple if in comparison to the submissions it has. The problem is construct 2D grid matching graph layout. The problem says you are given a 2D integer array edges. We are being given the list of edges representing an undirected graph of n nodes where edges of I is 0 ui comma vi, denoting an edge between the nodes ui and vi, and we have to construct a 2D grid that satisfies the condition. The grid contains all the nodes from 0 to n minus 1, and two nodes should be in adjacent cells horizontally or vertically if and only if there is an edge between them uh, in edges in the given list of edges. It is guaranteed that edges, basically this vector of integers which was being given to us, can form 2D grid that satisfies the condition. So we have to return the 2D integer array satisfying the conditions above. In case if there are multiple solutions, we can return any one of them. So it would be a case like we are being given the edges 0, 1, 0, 2, sorry, 0, 1, 0, 2, 1, 3 and 2, 3. So 1, 3 and 2, 3. There is a graph like this one, and we have to create a grid of size 4. Basically, the total number of cells in the grid should be equal to 4. And as you can see that there are two edges for 0. 0 is connected to 1 and 0 is connected to 2. So in this grid, this thing should hold on. If you are placing 0 here, then on one side there should be 1 and on the other side there should be a 2. Right? This is the problem. And it should be true for each and every node. Like this 2 is connected to 0 and 3. So there should be a 3 here. And you can see that all of these people are happy now because they're connected to the people they were here. Okay, so is the problem clear for what we have to do? Yeah, after but can you tell me, are you writing on OneNote or any other writing part platform? Okay, so uh, currently I am using GoodNotes, and I think almost everyone uses this on Mac or iPad. So I'm not sure if it works on Windows or not. I got to know about this on Mac only. Okay, so guys, um, yeah, if it's clear, that's good. So let's take another example. 0, 1, 1, 3, 2, 3, 2, 4. 0, 1, 1, 3, 2, 3 and 2, 4. 2, 3 and 2, 4. These are the four nodes. Sorry, five nodes. So they can be represented as this. Um, 0, 1, 3, 2, 4. Probably the main reason behind giving this example was to uh, let us notice this, that it's not necessary that there will be more than one columns or more than one rows. The 2D grid might actually be 1D only. It's fine even if there is only one dimension in the grid. And similarly, you can look at the third example as well. There are a lot of nodes, so I think it's better if you just if we just look at it here itself. 0 and 1 are connected. So 0 and 1 are coming uh, with each other. 0 and 4 are coming with each other. 0 and 5 are coming with each other. 1 and 7 are coming with each other. 2 and 3 are coming with each other. Similarly, 2 and 4, 3 and 6, and so on. I think I got the idea. And at the same time, if 2 and 4 are coming together in the grid, there should be an edge between them. It cannot be a case where um, there are two people coming together in the grid, but there is no edge between them. As we were being told that two nodes should come together in the adjacency list, horizontally or vertically, if and only if there is an edge between them. And we are being told that it is guaranteed that the given list of edges can form 2D grid that satisfies the condition for sure. So we can use this information that whatever graph which we have been given, or the list of the edges which we have been given, can actually form sorry, So whatever uh, list of edges we have been given can actually form a grid. This is something we are being told. So let us assume that uh, edges, like we have been given the list of edges. We don't know how will we create this grid, but we know one thing for sure, that there will definitely be a grid at the end of the day. Either it can have both rows or like the number of rows to be greater than 2 and the columns as well greater than being equal to 2, or there might be one column multiple rows, or there might be one row and multiple columns, right? These are the only three possibilities for the answer. Now, can you guys notice something related to these people or these people or these people? Can you guys notice something? You have 30 seconds. Try to think and tell me that in this complete grid, if I like when I'm not having any idea of how to solve the problem and I have to start from somewhere, I have to uh, like I have to think about something. So why thinking about these cells would be better than thinking about any random cell? What is special among them? Their degree is 2 at max. Are you sure it is 2 at max? Are you sure about the term at max? Yeah. By the way, you're partially correct, or maybe actually correct that for these people, they are having only two neighbors. These are having the least number of neighbors. This is the very first thing. The second thing is these people are only four in count. If I have been given a very big grid, no matter how big the grid is, the number of corners will always remain four, right? So this was the reason that if I don't know about anything, I first tried to think about them. Secondly, uh, wait, whatever list of edges we have, let's try to create an adjacency list for them. Since it is a problem of graphs, it makes sense to think about the adjacency list as well. So we have been given 9 nodes: 0, 1, 2, 3, 4, 5, 6, 7, 8. 0 is connected with 1, 4, and 5. 1, 4, and 5. 1 is connected with 0 and 7, or maybe we can see from here itself 0 and 7. 2 is connected with 3, 4, and 5. 3 is connected with 2 and 6. I think you are already getting an idea of what will be the observation. 4 is connected with 0, 4, 6, 7. 0, 4, 6, and 7. 5 is connected to 0 and 2. 6 is connected to 3, 4, and 8. 7 is connected to 1, 4, and 8. And 8 is connected to 6 and 7. So maybe you can already observe it on your own that all the corners will have two neighbors. So I might not be able to identify, uh, or maybe let's take this example. If I have a crate which contains a lot of nodes, then I will have too many nodes which have two neighbors. Sorry, four neighbors. I will have too many nodes which have three neighbors. But I will always have only four nodes which are having two neighbors. I can easily identify them, right? I can easily identify them. So can I say I will be able to find out all four corners? I can easily find all four corners, right? At the same time, we don't really know whether we will always have four corners, or um, this kind of situation might come someday where you have two nodes at the edges and all the other nodes having two edges, like this case. So can you identify this case? Like if you someday get a case where you don't have four corners, instead you are having only one dimensional matrix, how will you identify them? uh, Obviously this is going to be an easier case where you don't have a matrix, instead you are having just 1D, one dimension. Because if in the given edges, like from the edges, when you create the adjacency list, if the answer is like this one, which is having only one dimension, either in this way or in this way, then there will be two nodes in the adjacency list. There will be two nodes in the adjacency list where their degree will be equal to 1. Two nodes with degree equal to 1. And once you find out both of these nodes, you know that one of them will come at this place, one of them will come at this place. And in the original graph, if you just run up a normal DFS or BFS to find out the path from this node till this node, you can easily get this, get all the nodes. Let me take one example. If this was the given problem, 0 1 3 2 4, 0 1 3 2 4, no. Okay, yeah. So based on the edges you will have, the adjacency list will look like this, where 0 will be connected to 1, 1 will be connected to 0 and 3, 1 is connected to 0 and 3, 3 is connected to 1 and 2, 2 is connected to 3 and 4, and 4 is connected to 2 only. So from the adjacency list, you already know that you will have uh, 0 coming up at one of the points and 4 will come at the other place. And you don't know about the place where 1, 2 and 3 will come, but you can find it out by running a DFS from 0 till 4, right? By getting the path from 0 to 4, because this grid is just another representation of the graph. It is still the graph, the original graph which we had. We have just changed the way of representing it. That's it. Okay, so guys, does this thing make sense? We can run up a DFS from 0 to 4. 0 has only one neighbor, that is 1. For 1, it has two neighbors, 0 and 3. 0 is already visited, so it will go to 3. For 3, it has two neighbors, 1 and 2. 1 is already visited, so it will go to 2. Now 2 will have two neighbors, 3 and 4. 3 is visited, so it will go to 4. And yeah, you got the complete path. Does it make sense? In this way, we can find out the answer for the case where we are having uh, 1D answer. The answer will be a 1D matrix. And how will you identify that uh, the given edges will have this kind of an answer? You can create an adjacency list and then check if there are two nodes with degree 1. Then uh, this will be the answer. Otherwise, if we find out that there is no node with a degree 1, because if the answer is actually a grid, in that case there will be no node with a degree 1. Instead there will be 4 nodes with degree 2. So we can iterate over this adjacency list once again and find out all the nodes which are having degree 2. So let us say we got the 4 nodes as 2, 4, 9 and 7. Let's say these are the 4 nodes which had degree equal to 2. So you know that a node 2 will be one of the edges. Sorry, the node 2 will be one of the corners, and then the node 4, 9 and 7 will be the other corners. But there is a catch. One of these three nodes will lie opposite to the node 2 in the grid. Let's say the node 4 is here, and then the other nodes can be in any order, uh, uh, because if you can have 1 2 3 4 5 6 7 8 9, let's say that someday this is the answer for some given inputs, then 1 2 3 4 5 6 7 8 9 would always be the answer as well. Like the transpose of the matrix would always be the answer. So we don't really care about 7 like coming up here or here. We mainly care about which node is at the opposite end, because it must stay at the opposite place. So guys, do you have any idea of what will you do in this case? Now the progress we have made so far is, we know that the matrix here, uh, the answer will be a 2D matrix. Otherwise we would have already solved it if it was a 1D matrix. Now for the 2D matrix, you know about all the 4 corners. It doesn't really matter which corner you pick up at the first place. Let us say, yeah, the 4 corners are C1, C2, C3, C4, and you place C1 here. So how will you know which of the other remaining corners will come here? You have 1 minute to think about it. You have a minute. Try to think about it. Okay, somebody said yes, it is easy problem now. Yep. Uh, Now there are only 2 things remaining, I think, and it is very doable now. Once you guys figure out, you can mention it in chat. Okay. Um, let's just do it. See, uh, I know that the corner which would be on the opposite side among these three must be the farthest one, right? If let's say there are 10 rows and 4 columns, then whichever corner comes up here would be at a distance of 3. Whichever corners comes up here, it would be at a distance of 9 from C1, and whichever corner comes up at this place will be at a distance of this 9 plus 3, that is 12, right? in whichever way you go. So, in a nutshell, one thing which I'm certainly sure of is these two corners will be closer to C1 in comparison to the corner C4. So I can just find out any one of these corners, or maybe I can just find out the yeah, if I want to find out the corner opposite to C1, I can just find out the farthest corner, and like I can just apply a DFS from here to find out the distance to all the other nodes, not in this grid, but actual in the actual graph which I have. In the graph, if I run a DFS from C1, and it will go up node to node at every place, and will somehow reach C1, C2, and C3, C2, C3, and C4. Then I can check up their distances, whichever node is closest or the second closest. These are the adjacent corners, and the node which is farthest is the farthest, like basically the opposite corner. I don't really care about which node I pick up among C1 and C2 and C3 among the adjacent nodes, but uh, what I did was yeah, just 1 second. Yeah, so what I said was I know about the corner one, like I have just picked up any one of the corners as the first corner, and then I ran the DFS for all the other corners till this one, and this one, and whichever one came as the smallest distance, came at the smallest distance. I just said that hey, let's consider this one as the second column corner, and then I don't really need to fix these two now. Like you can fix them on the basis of their distances, but it's fine even if you just know about C1 and C2, because now from C1 to C2 you can find out all the nodes in the way, like all the nodes which are coming up here, here, and here, by running a DFS, or actually a BFS, from C1 to C2. Like you can have a BFS from C1 to C2 to find out all the nodes in the shortest path. Do you guys agree that this is the shortest path from C1 to C2? So whatever shortest path we get via the BFS from C1 to C2, it must be this path itself, because any other path from C1 to C2 would definitely be bigger. Guys, yes or no? We know that uh, from C1 to C2 there is only one shortest path, because any other path from C1 to C2 would have more number of nodes being involved in the way. So I can just run a BFS from C1 to C2 to find out the nodes in the way, and I will be able to get this node, and this node. I will be able to find all of these. Now let's look at the perspective for C1. It had two neighbors. From the list of edges that I was being given, I know about all the, like I know about both the neighbors, right? I had been given the edges from which I calculated the adjacency list. Now with the help of this adjacency list, I know about both of the edges, both of the neighbors for C1, and I have already placed one of them. So do I know which guy should come up here? Yeah, I do know about it, because I knew C1 will have two neighbors. I have already placed one of them. So there is only one place where the other neighbor can come. Look for this guy. He had three neighbors, 1, 2, and 3. Two of them are already placed. So you can place the third one. Look for this guy. Similar, same story. Two of the neighbors are already placed. So you can place the third one. Similarly for this guy. it had 3 neighbors, 2 of them are placed, so you can place the third guy. Similarly for this one, you can again place the third guy. And the same story will now repeat for these people. This guy had 3 neighbors, 1, 2, and 3. 2 of them are already placed. You can place the next one. Similarly, for this guy, it had 4 neighbors, 3 of them are placed. You can place the fourth one, and so on. So, what we will do is we will go row by row for each node. Uh, we will find its neighbors. We will find its neighbors which have already been placed, like the neighbors which are already placed. Below it. So if we were checking for this guy, we found the 3 neighbors which have been placed. We got the 4 neighbors which had to be placed, and then the fourth one which, like, one of the neighbors would have not been placed yet. So just place it and then go on for the next cell and so on. I hope this problem is clear, guys. Yes or no? And let me show you a dry run as well for this example. So yeah, maybe I can draw it here itself. This is the example 3. Dry run for the example 3. So first of all, let's find out all the corners. The 4 corners are 1, 3, 5, and 8. 1, 3, 5, and 8. Let's consider 1 to be placed at this place. And among the other 3 corners, let's find out the closest one. There will be 2 corners which will be close. Uh, yeah, by the way, till this point, when you have just found the corners, you don't even know about the dimensions of the grid. You don't really know anything about it other than the corners. So um, from the node 1, you can go to node 0 and 7. From 0, you can go to 4 or 5. From 7, you can go to 1, 4, and 8. So 4, yeah, there is this 4 and this is 8. And yeah, we found out 8 and 5. Both 5 and 8 are coming up at distances 2 from the node 1. So now we know that since these nodes are coming up at a distance of 2 from the current node, then it means that the matrix would be of size 3 by 3. Actually, you don't even need to know about the 3 by 3. You just know that the closest node, the closest corner, it as a distance is at a distance of 3. So you can place the node 1 here. The closest corner, that was 5, coming up at a distance of 2. So you know that there will be three columns, and you can place 5 here. Now it's up to you if you want to find out the number of rows uh, by finding out the distance to the second closest corner, or you can just say that the number of rows must be equal to n by number of columns, because number of rows into number of columns must be equal to n. And uh, that's it. In this way, we will be able to figure out the number of rows and number of columns. Now the closest path from 1 to 5 was by going through 0, 105. So 0 will come up here, right? You can actually just create a function with name maybe get path, where you will pass the first node and the second node and the adjacency list, and it will tell you the path from the node u to node v. uh, that is what I had done in my implementation. So once you are done with this, the first row, after completing the first row, you can just go cell by cell. Like for first cell 1, it has two neighbors 0 and 7. 0 is already placed, so you can place a 7 here. Then go to the node 0. It has three neighbors 1, 4, 5. 1 and 5 are placed, so 4 must come here. Place 4 here. Then you have 5. 5 had two neighbors 0 and 2. 0 is placed, so place 2 here. Then you have the node, the cell 7. 7 had three neighbors 1, 4, 8. 1 and 4 placed, so place 8 here. Then you have the cell 4. 4 had four neighbors 0, 4, 6, 7. 0, sorry, 4 had 0, 4, 6, 7. Okay, I think I wrote it wrong. 0, 2, 6, 7. 0, 2, 6, 7. Yeah, so 0, 2, 7 are being placed, so 6 must come here. And then for the node 2, it had three people 3, 4, and 5. So 4 and 5 are here, so 3 must come here. And yeah, we have completed the grid. I hope this dry run did help you. So guys, is this problem completely clear? Is this crystal clear or not? Like just try to one of these in chat, crystal clear or not. Basically, if you have any doubts or you feel that the explanation is not up to the point now and you want something else as well, then just please mention. Which pen tab do you use to write? I use Huion tab. Huion pen tablet H580X. This is the model number. And yeah, I can completely recommend this one. I've been using this since 2 years and it is working completely fine for me till now. Okay, let's move on to the next problem. Oh, sorry. Let's move on to the code then. So this is a code snippet for finding out the path from source to destination. This is something I had already written and I have kept it in my templates. So whenever in any problem I have to find out the path from some node to some other node, I just copy paste this template and I can use this function. If you want, you can also copy my code. Like you can also keep this code with you. It is tested as well. And this was the main function which we had to complete. So first of all, I'm generating an adjacency list from the given list of edges. Then I'm checking for the edge case where we have only one dimension. So for that case, it's up to you. If you want, you can have another function as well, which will be a bool function that tells you um, is the answer having one dimension or maybe some better name. So you can maybe create two functions. One will tell you if the answer will have only one dimension or not, and the other function will return the answer with one dimension. Or you can do it with like me. I created a function with name handle one dimension. This is basically the edge case. Inside it, I have been finding the two nodes which are having degree 1. I named one of them as source and the second one as destination. If I don't find two nodes with uh, degree 1, in that case I'm just returning an empty vector of vector, and wherever I get that in my main function, I will just check that, hey, if I have not got an empty array as the answer, in that case it is my answer. Otherwise, if I got an empty array, then it means that this is not having the edge case, and I will move on to consider it as the main problem. uh, yeah, just as a disclaimer, this might also look a bit complicated to some people, uh, and it's totally fine if you like to write a longer code but a cleaner one. Then we are finding out all the corners. This is also simple. For all the nodes having the degree greater than 2, just continue, and the nodes which are having the degree being equal to 2, just consider, like, just push them into the corners vector. Then I am calculating the distance from the corner 0 to all the corners. Now in this case I am calling this function getPath 3 times, which will uh, run a BFS again and again. So 3 BFS would be run in this case, like we will run 3 BFS. But you can actually avoid it. You can just run 1 BFS and then find out the distance to all the other 3 corners in one go. But for that I would have to write a BFS function here outside, and I would have to write longer code. So that is why I just did run BFS 3 times, because it won't really make much of a difference in the time complexity. Then I found the, like, I found out the closest corner, and on the basis of that I uh, set the value of the number of rows and the number of columns. And during the contest I had added one more line: rows into calls should be equal to n. So this will be just a checker that rows into columns must be equal to n, otherwise we are doing something wrong, so it will throw a runtime error. But it's fine if we don't include it. Then we are creating this answer vector with the dimensions which we have figured out, and for the first row we are just running up a BFS from corners of 0 to the closest corner, and after that we are going row by row for each and every cell, as we had seen uh, here. For each of these cells we had come one by one, and we had looked up in the neighbors of which cells we have already, which nodes we have already placed, and then we were looking up at the adjacency list, that which nodes do we have to place. So that's what I'm doing here. I am first of all finding out all the neighbors which I've already placed and storing them inside a set, and then for all the neighbors which I have, I am checking that if there is any neighbor which is not placed it, then just place it. Like if I was checking for this cell on all the neighbors, then whenever I found out that, hey, uh, 7 should have been connected to 1, 4 and 8, it is connected to 1 and 4, so I was placing 8 on the cell just below it, that is in the next row at this place, and then I'm just breaking it out. And even if I don't write the break statement, it won't matter because all the other neighbors are already placed. And then at the end of the day, I will run the for loop till the last second row, because once the for loop for the last second row is done, the last row would have already been written. The matrix would already be complete, so I can run it till rows minus 1 and then return the answer. So I hope it makes sense. Similar question for practice. Um, I think I've never done a similar question in this for this one. It was first time for me as well. Okay, so should we move on? Yeah, by the way, talking about time complexities, this get path function works in big O of n. This thing will work in big O of n plus m. Like if you see, the number of edges won't be too much greater than n. The number of edges would be comparable to the number of nodes, since uh, any node can have at most 4 edges. So the number of edges must be less than 4 into n, because not even all the nodes will have 4 edges. And here, this is gonna be having a time and space complexity of big of n plus m. This will have big of n plus m. This will have big of n time complexity. Then this will have big O of, again big O of n time complexity, n plus m time complexity. This will also have somewhat big O of n plus m time complexity, and this will have big O of n time complexity again. So overall, I think we can just say that the time and space complexities will be big O of n plus m. Other than this part, like here we are actually having some log constant factor as well, but in this set we will never put more than 3 people, so we can consider this as a constant space as well, constant time and constant space.